Okay, AMA, we're dealing with 2.6. Our learning target is I can take derivatives implicitly. This is known as implicit differentiation. And we're going to see what's happening. It's really nothing more than the chain rule. Let's have some review. Let's just say that we're taking the derivative of f of x to the fourth power. Now, kids could say, well, what's f of x? Well, we don't know. They never tell us. So I need to take the derivative of f of x to the fourth power. How do we do that? Take the derivative of the outside. And that's, would you agree, 4 f of x to the third? Yeah. Are we done? No, then what do? We take the derivative of the inside. That's the essence of the chain rule. Derivative of the outside multiplied to the derivative of the inside. Now, of course, you can look at this and say, well, what does that have to do with anything? Oh, actually everything. Imagine that you were tutoring kids in the coach program, and you were helping some freshmen out. And they're brand new to algebra, and they're looking at this f of x, and they're going to say, I was absent. My teacher was talking about this f of x. I don't know what he or she's talking about. I'm confused. And you would tell them f of x is really just y. Would you agree with that? So let's revisit this. How do we take the derivative of y to the fourth? And the answer is exactly the same way that you just did. What should we do? Bring down derivative of the outside, 4y to the third, derivative of the inside. You'd say, well, how do I write that? Well, you could write it as dy dx. And that's called implicit differentiation. Y is really like an f of x. So when we take the derivative of it, we have to understand it's really doing what we did over here. And instead of writing f prime of x, we could just write dy dx. Okay, that making sense, I hope? Let's see it in motion. Let's see 2 examples today. Like I said, short lesson. That's good. You could say take the derivative here. Find y prime, or find dy dx with respect to x, okay? So in other words, they're saying find dy dx. What's the derivative of 5x squared? What would we get? 10x. What's the derivative here? Be careful. Negative 4y squared. What do you think? Minus 8y to the 1. Chain rule. Dy dx. Now, right there, somebody might say, you just lost me. Look, dare I say, wouldn't it be the same thing as if you had f of x to the second, and if you did that, you'd bring down your 2, and then you'd have f of x to the 1, and then you'd say, oh, take the derivative of that inside? Do you see what I'm getting at? That derivative of the inside, that f prime of x, that's your dy dx. Okay, so just want to make sure we're seeing that. What's the derivative of a constant of this 10 here? 0. Now, guys, what you're going to have to do is solve for dy dx. Dare I say it might be easier to move this 8y dy dx to the right-hand side. Move that to the right. Then what? To get dy dx alone, what you want to do is deal with that 8y out in front. Now, the 8y is being multiplied to dy dx, isn't it? So we're going to divide by 8y. And what are we left with? Maybe this can look very strange. 10 over 8, you can divide out of 2. You'll get 5/4. But that's 5/4 times x over y. 5x all over 4y. What's very different with this derivative is if you want to find the slope of the tangent line, guys, not only will you substitute in an x coordinate, you'd also have to plug in the y coordinate too. We doing okay? That's really all we're doing today. It's all about the chain rule. Last problem, and this is something well worth talking about. We can say, hey, find the slope of, well, we got to find the slope of the normal line. Now, we'll get to that in just a moment. We can say, here's a point, 0, 3. I've got my x coordinate. I've got my y coordinate. And to start us off, we're going to take our derivative right here with respect to x. What rule do we need to use to do that? The product rule. I've got two functions multiplied together. Like here's a u, here's a v. Hopefully you remember it's uv prime plus u prime v. U. So I'll go sine of x. And then I'm going to say v prime. What's the derivative of y squared? Help me. Yeah, 2y dy dx. You got it. Very good. Then I'm going to say now I need u prime v. What's the derivative of function u? What's the derivative of the sine of x? Cosine of x. And then you'd say, well, what's v? Well, v is just y to the second. Now, guys, what you just dealt with is the yellow highlighted part. There's still this 4y that I have to take a derivative of. What's the derivative of 4y? What do you think? 4 dy dx. And somebody might say, wait a minute, what are you talking about? What if it was 4f of x? Wouldn't you say it was 4f prime of x? If I said take the derivative of that? There's no chain rule right there. You just say take the derivative of your function. Well, how do we write that? F prime of x or dy dx. And then we're going to say, what's the derivative of 12? 0. So at this point, you could do a little bit of cleaning up. But I guess I really want to tell you early that there are two dy dx's. And that can scare kids a little bit. So look, I'm going to put my 2y out in front here. Here's my 2y sine of x, dy dx. And I'm going to bring this 4 dy dx closer. And at the same time, I'm going to move this y squared cosine of x to the right side. Because ultimately, I'm trying to solve for dy dx. Right? And if I'm solving for dy dx right now, guess how I can get dy dx alone? Factor it out. You know it. You know it. So now look, if I factor dy dx out, I'll have a 2y sine of x plus 4. And wow, we are almost done solving for dy dx. Dy dx is just going to be this thing right here where we go ahead and this is the algebraic answer that you would get. Now, I do want to tell you at this point we should plug in the point 0, 3. I'm going to draw a vertical bar and show the 0, 3. That vertical bar means now plug in an x value of 0 and plug in a y value of 3. So what would we get? We'd get negative 3 squared cosine of 0. Down below we'll have 2 times 3 sine of 0 plus 4. And what's the cosine of 0, by the way? It's 1. And isn't the sine of 0 a 0? And all that gets multiplied is going to cancel out. So I'm going to have 3 squared, which is 9, and then put a negative out in front of it. So I'm going to get negative 9/4. And that's the slope of your tangent, right? What's the slope of your normal? the opposite reciprocal, right? Normal lines are perpendicular, so you have to take the opposite reciprocal. So, guys, to finish this up, they want the equation of that normal line. And we've got 0, 3, and we've got our m is 4/9. So we could say y minus 3, here's 4/9, x minus 0. And that would be the equation that you could come up with. Yeah, are we doing okay with that? I want to show you one alternate way that you could have solved when you know a point. Watch, I'm going to draw this over here, and I'm going to say method 2 off to the side here. And I'm going to have our sine of x, 2y dy dx, plus cosine of x, y squared, plus 4 dy dx equals 0. If you know early on that you're going to plug in 0, 3, feel free to plug it in immediately. Do you get what I'm saying? You're going to plug it in at some point. Now, sometimes kids will say, Mr. Dobner, why in the world didn't you show that to us earlier? Answer, sometimes they don't tell you to plug in a point, and you got to do the factoring that we just did, right? But look, if I know already that my x is going to be a 0, oh my gosh, maybe you can see what I'm talking about right here. Here's an immense time saver. Look at this. Check this out. Sine of 0 is 0. That whole mess goes away. You see what I'm talking about? Sometimes that's, just like a wonderful, look, cosine of 0 is 1. You'd say I'm getting 9, not 9 squared. 3 squared is 9, pardon me. And then you'd say, well, my gosh, look how much easier it is to solve. Wow. Dy dx is negative 9/4. Look at that. So if you can plug in a point, my advice to you is plug it in early. If they don't specify a point, you're probably going to have to do some factoring like we did over here. So that's why it's good to see the two methods. We're going to have a worksheet, and we're going to do 1 through 21, the odds.